we are going to investigate what happens to the current through a bulb when you switch on. To help us do this, we're going to use this board. Nice and simple. We have 3 1.5 volt cells in series, a switch, a bulb and a resistor to limit the current. When I close the switch, the bulb comes on. We have 3 terminals here, and this will help us measure the voltage. We can measure the voltage across the resistor. Knowing the value of the resistor, we have the current. If I measure from ground to the top and take that voltage there and subtract the voltage across the resistor, I will be left with the voltage across the bulb. These 3 leads go to the Alba data logger, and we're going to use an application in the Alba software for this experiment. So let's wire it up from the top into channel 1, in the middle into channel 2 and the ground. I am now ready to start the experiment. Let's launch the software. We will load an application. It's a physics application and it's called Current in a Bulb at Switch On. Let's read a little bit about it. What we would like to get to is this circuit here. This is the circuit diagram of the board that we just wired up. Our 3 cells in series, close the switch, current can flow around our loop. We can measure the voltage across the resistor. We know the value of the resistance, we have the current. If we measure the voltage from that point to ground and subtract the voltage across the resistor, we have the voltage across the bulb. And there are other things here for the student to look at. Let's start the experiment. We'll say go. The graph of the voltage across the bulb against time is set up for us, and the graph of current against time is also set up. Notice that the voltage across the bulb is the voltage of the supply minus the voltage across the resistor. The resistor value in the circuit is 10 ohms, and we have a table set up here which we'll look at in a little bit more detail shortly. Let's say OK, and we're ready to go. Switch on the bulb. So we'll press the switch on the board, and we have 2 graphs. The voltage across the bulb is going up and reaching a steady value. The current through the bulb is going up to over 0.2 of an amp, and it settles out at a steady value of 0.05. That value there is more than 4 times the final value. So there's this sudden great big current, and then it settles down again to the steady value of the current that would flow through the bulb in normal operating conditions. Let's look at our table of results. So we'll come up to the top of the table. We have our time column, the supply voltage, and we have the voltage across the resistor. So if I subtract that away from that, I would be left with the voltage across the bulb. And we can see that we've got an odd point here. Let's drag this in. We have an unacceptable reading here, and I'm going to double click on that use to say ignore. And let's now look at the current in the experiment. The current is decreasing. If I know this current and I know the voltage across the bulb, I can calculate the resistance of the bulb. So let's do that. Let's fill this column with the resistance of the bulb. So I select this column and I'm going to do a calculation. So I go to my column calculator, and the resistance of the bulb is equal to the voltage across the bulb divided by the current through the bulb. You can type these or you can press the buttons. Okay, and I have my resistance values here. How does this resistance change with time? So let's click on the time axis and go to the quick graph icon and click, and there is a graph of how the resistance of the bulb changes with time when you switch it on. It goes up very low to start with, and then goes up and reaches its final value a little more than 0.15 of a second, where it's a steady value. This is nice and quick to do, this experiment, and because it's so easy to do, you can then start to explore, do other bulbs behave the same way? Do they all show that kind of characteristic? And you perhaps can gather from the way I'm saying it that they don't. If you replace that particular bulb that we use, that filament bulb, with a lens end bulb, totally different behaviour. Okay, this experiment is one of the Alba software applications. If you want to know more, visit the website at www.djb.co.uk. Thank you.